We're already the last session of a great day.
Hi everyone, thanks for coming out. A little concerned about all the food, candy and everything else out there. Everybody's going to start to zone pretty soon. I'm Mike Lee from Northern Weathermakers, and we're going to go through a brief overview of system integration. We're going to have plenty of time for question and answer at the end. So if you have any questions, please make note of it. And I'm going to start out here with Donnelly Phillips. So buildings energy costs, everybody sees the cartoon out there. It does go out the window. Your money's just flying out the window. The question is, do we do lighting? Do we put a new burner in? Can we get more efficient pumps? Can we put frequency drives in? There's so many different questions, and it really boils down to, in most cases, many cases, with building automation, you can save more money than a lot of the other energy measures that are there. People think of building automation as far as this big, expensive investment. It truly isn't, and we're going to explore this in the slides coming up. So, building energy spending, 43%, 60, 70% at different companies, depending on what the usage is. We have to control the energy related to your HVAC equipment. With a building automation system, you're able to have precise temperature control. Email alarming. It's nice to know that you're having a wing go down or the chiller went down or boiler went down before your customers or employees of your company even notice. Power monitoring. Power monitoring is big. It's nice to look at your usage on a minute, hourly, monthly, annual basis. Find out what's happening. Why are we using too much kW at night? What's running? The parking lot stayed on, or somebody overrode this or that. Without power monitoring tied into a tight building automation system, you truly don't know what's happening until you receive your electric or your gas bill. It's a real important part of the system. Global integrated control. You could have multiple buildings across the state, you could be across the country, you could be international. With today's technology, you're able to access everything from one web browser. Advanced energy reduction programming. There's a lot of building automation systems that are out there, new ones, old ones. The majority of them are glorified time clocks. They give you the feel good of being able to set maybe an occupancy schedule. They allow you to set a temperature, but they're not truly managing your building for optimal energy usage or energy reduction. Also, building automation systems can integrate easily with the system you currently have. We're going to use some examples coming up in a little bit as far as how we've integrated into different systems, the return on investment, rebate dollars available, and the benefit to the customer with integrating the new technology with some of the existing technology you may have. There's a lot of myths about building automation systems. One is you must add building automation to the entire building. Not the case. You add building automation where it makes sense, where it's going to save you the most money, or take care of problems such as comfort cooling. Next one is you have to replace a lot of existing equipment. Again, we can integrate into what you have existing. Expensive? It's not. With the return on investment that's out there now, there's just not expense. Even without the rebate incentives, it makes sense to move forward with building automation. The second you have a rebate check coming with it, it's a no-brainer. Complex and time-consuming. 95% of the projects we do them small, we do them big. The customers and or employees or tenants have no idea that we're even a building working on it. As far as downtime, switching over from a system that's running under pneumatic, electro-pneumatic, or manual control, it's very easy and very seamless. We want to automate only parts of the building that have maximum return on investment and maximum rebate dollars. There's been many times we've been brought into a facility, they want to automate the entire facility, we walk through, we figure out, okay, what's going to save them the most money, what's going to give them the most rebate dollars, what's going to allow this project to move forward. If you go to your CFO, owner, board of directors and tell them, hey, we can take care of a third of our building, reduce our energy usage by 35, 40%, and have a return on investment of 1.1 years. That project's moving forward. A lot of times if you look at an entire facility, an entire project, We're going to automate the entire campus. You're getting a lot of bells and whistles that aren't going to necessarily save you a tremendous amount of energy. So it's really important to look at the right parts of the building. Hybrid systems, low cost, maximum return on investment, maximum incentives. Meaning that you specifically look at makeup air equipment, maybe chiller or boiler control, VAV control with minimums, maximums. You look at specific areas and you integrate automation into that to make everything right with your company or your energy quest. So here's just a slide of a building automation system. They're all graphical, they're on a front page, on a web page, and you click on it, you see tons of buildings throughout the city of Chicago. And you can pick any of them. A lot of them can't even recognize what some of the buildings are. Each one of these buildings are bringing in no less than 60,000 CFM of outside air per minute. If you figure 60,000 CFM and up is being pumped into those buildings and for fresh air. Now we have to realize that we have to heat and cool that air before it enters into the building. You have pressurization issues if it's not controlled correctly. Everything could spiral downward, bringing in that much air in from the outside. So if you can save under tight control in any of those buildings, I'm not talking about VAV boxes, boiler control, chiller control, just on the makeup air coming into the building, if you can save a degree or two of precision in the heated or cooled air coming into the building, absolutely substantial, and you're looking probably about $30,000 to $40,000 in rebate incentives. That's for tight control off a few degrees. It's really nice to be able to look at an air handler, see what's happening with the chilled water valve, the hot water valve, if the motor's turning on, do you have proof of airflow? In a lot of buildings, you can do this remotely. You can do it from a cell phone, you can do it from your office, and it's just great to have everything at your fingertips. The best control system that's installed, though, is one that does all this by itself, that you never have to look at, that you call our office and say, hey, I forgot about my password. What's my password? How do I log in? It's been running great for years, but the CEO wants to have a report of when things are running or what schedule we're on occupancy or not. So the nice part about building automation is when it's done, it's put in, installed, and commissioned correctly, you do not have a problem where you have to babysit it and sit in front of a computer all the time. And that's the end quest. We want to control your environment and we want to conserve energy. So integrating automation into your existing system. Now the watch on the left is a Timex watch. There's absolutely nothing wrong with it. That could be 30, 40 years old. And that's old technology. We have the watch on the right, which is a new, smartwatch. And they both tell time. Just as your old system that you have, be it pneumatic, electro-pneumatic, is still controlling your HVAC, but we can integrate the new technology with the old. So to be clear, you currently have a control system on any piece of equipment that you have. How you integrate it with the new to give you optimum energy savings is the direction that you're going to want to go. So right here, these are pneumatic actuators. The first one is pneumatic valve actuator. That's a big valve, about a 6-inch valve. It has a big diaphragm on it to open and close that valve. And to replace that, it's in the thousands of dollars. So if I wanted to put in a digital valve, that would be awfully costly to replace that, or digital actuator. The one far on the right is an old Series 90 control. This is commonly used for dampers and or valves. Series 90 control was a proportional signal that would open and close it. To replace that Series 90 control is very expensive. So if you look at your facilities, you look at your hospitals, manufacturing, office buildings or whatnot, you start adding up these valves and these actuators and what it would cost to put new ones in. And guess what? The project's so high, you're not going to have a return on investment. And it's going to be difficult to push it through management upstairs. This is typical control of a system. You have a pneumatic thermostat, you have a pneumatic controller, and then you also have a pneumatic actuator. I could switch that up and say it's a Series 90 control. We have a proportional electric thermostat going to a proportional control, going to a mod motor with proportional control. In either case, it's outdated technology. You like to have it out of your building, you want to go with building automation. This is the new system. This is how you integrate into the existing control system that you have. We have a new digital thermostat. state-of-the-art digital sensor, which to the right communicates with digital controller, and then that controller tells the transducer how much air to send to that old diaphragm to open and close the valve. So simply what we've done is we've taken pneumatic control, which has no intelligence whatsoever. We took pneumatic control and we're controlling the end unit, the actuator, by allowing a certain amount of air through the pressure transducer to open and close that damper. Now if you say, well Mike, that's a waste. I have old pneumatics. Why do I want to go ahead and convert and put digital to control old pneumatics? Well, the nice part about it is if the valve breaks, if there's a problem with the pneumatic damper actuator, then go ahead and put in a digital one at the bottom. So what we do is we go from the thermostat to the control board, and now instead of taking the two wires going to the pneumatic transducer to send air to the damper, just extend those two wires to the new damper. And a slight programming change would take 2-3 minutes. Now all of a sudden you're controlling that damper rather than controlling transducer to send air. So in essence, you can go ahead and add automation to an existing pneumatic system. In the next 20 years, that pneumatic system will be converted over to digital at little to no cost for the integration. So integrated into existing automation systems. A lot of us over the years, and we're a full service mechanical contractor, so we've dealt with it separate from the controls end. A lot of times you're handcuffed by a manufacturer, you're handcuffed by a manufacturer that has a proprietary system. You're locked in a long-term maintenance agreements, may not have the service you want, you're just held hostage. It's very important to go ahead and start looking at the tritium systems that are out there. A pure tritium system, meaning that it's not locked down by a manufacturer, it's open protocol, other people can program it. If Northern Weathermakers doesn't do a good job for you, you can call in 30 other people within a 25-mile radius to take care of the system because it's an open architecture system. The other thing about the tritium system that makes it so appealing is if you remember back in the day when you install a video card in your computer or new monitor, you'd have to install drivers on a computer to communicate with it. It's the same thing with this. So if you had a different manufacturer system, say it's a Metasys system, Johnson Metasys, you would install an N2 driver to communicate with Johnson Metasys network. If you had Carrier CCN, you would install the Carrier CCN driver on the tritium box to communicate with that. If you had a building that had Carrier, Johnson, whoever else, we can communicate with all three of those on 3 separate networks. So it's really nice to be able to add a driver to a robust front end like this that's non-proprietary and be able to control it. Again, it talks to every network, open system, non-proprietary, and it hosts all programming and graphics, meaning that back in the day, you'd have to have a computer that would load all the software, keep all the trend data and whatnot. This little box, you plug the internet into it, and then you add the network controllers to it, and all the web pages are all contained within the Tritium controller, as well as email alarming goes through there and everything. You do not have to have a standalone computer to operate it. You can access it anywhere on the local network for your building, or if you open up ports to the outside, you can access it from home to take a peek at it. So rebates reduce your capital expense. Huge factor here, huge factor in our growth. There's nothing better than going in and doing an energy study, telling you exactly what you're going to save with new implementations, and then also saying, oh, when the utilities are going to commit with a check for X amount of dollars. It's a no-brainer. The utilities and what they've done to reduce their usage has been extremely beneficial to this industry, and most of all, not beneficial to contractors like us, but beneficial to the end users. There's nothing better to have a company be able to reduce their energy expenses, reduce their maintenance on their equipment substantially with a new building automation system, and at the end of the year, their bottom line's taller. They're making more money as a company at the end of the year. It's just good all the way around. So short return on investment, it keeps paying up dividends over the years. At one point in time, you're going to have your investment paid off, and then it's just free money coming in. So right here, this is a little picture of just a computer, a phone, a tablet, an iPad, and with it, you have no idea if you're controlling a brand new state-of-the-art tritium-based system, and you have no idea if you're dealing with a brand new state-of-the-art tritium-based system that's controlling old hardware, old actuators, and your existing control system. As far as ultimate control, you have this control at your fingertips. Down the line, what it's controlling, it doesn't matter because we're overriding, we're telling everything what to do. Short return on investment, a lot of different strategies and different things you can do. Right now, this building, it may be set to hold 100 people. We have X amount of CFM of fresh air that has to come into this space right here because we're all breathing. We put sensors in here, and all of a sudden, it makes it really nice because if we only have 4 people breathing in here, then we're only bringing enough air for 4 people. It really helps companies. Again, we talked about an excess of 50,000 cubic feet of air per minute coming in minimum in one of the high rises. Your office building very easily could be bringing in 15,000 CFM of outside air that has to be heated and cooled. So by putting in CO2 sensors, great return on investment, great incentives on that too. Something to definitely look at. Discharge air control, it's important. If your air handlers are putting out too cold of a temperature because you can't control it, all of a sudden your reheat coils are turning on to heat up the space because it just got too cold. Surprisingly enough, it's a real quick formula as far as figuring out how many BTUs per CFM multiplied by how many degrees of control will tell you exactly what we're saving on something. So tight discharge air control, very, very important. Occupancy sensors, just at the school up in Grays Lake, and they said, you know what, we love automation, but a lot of times teachers come in here at night and they do work and they might be here a little later. So we want to keep the system going until 7 o'clock or 8 o'clock just to make sure, even though the majority of the people are out of school by 4:30. We put in occupancy sensors of their building automation system. If someone decided to work late, we left the system on. Again, by utilizing this technology, we really helped out the end user because they're not letting everything run all the time just because someone may show up. Space temperature reset. Everybody's been in a space where all of a sudden it's 80 degrees, 75 degrees. We get down to 72 degrees, people start freezing. As we start getting closer to a set point in a chilled water system, we want to raise the chilled water in a hot water system as it gets warmer outside, or more importantly, if we don't have the demand needed in the space, we will go ahead and reduce the hot water temperature. A lot of technologies look simply at outdoor air temperature. Based on outdoor air temperature, this is what I'm going to do. But what I care about is, based on outdoor air temperature, based on predictive scheduling that comes in from the weather service as far as what kind of front we're having come in, and based on what's actually happening inside the building, are we at set point or are we not, I want to make those decisions from there. So you can do a lot with a finely tuned automation system. To the end user, it's transparent. Building pressurization, something that's overlooked. Every once in a while you walked into a restaurant and couldn't open the door because we're exhausting so much air out of it, and we all get it, we feel it, we're in a business, we know what it is. We have it where we're pulling air in through mortar joints, we're pulling air in through cracks in the windows, glazing through everything. Or we're bringing too much air into the building where we have to heat and cool it and we're overpressurizing the building. It is so important to take care of your building pressure. Put multiple sensors in there tied into your building automation system and really have the building running the way you want to do it. Huge cost savings. I can't tell you, how important it is to do that. We all know about boiler control. We talked again about being redundant here, but with boiler control, if it's negative 20 outside, we're going to go to 180 degrees. If it's 50 degrees outside, we're going to let it drop down to about 110 degrees if it's a non-condensing boiler. But we also have more than that. In most cases, you have more than one boiler. So we want to stage them. We want to lead lag the system. We want boiler number 1 turning on first, then maybe 3, then 2, next cycle, then 3, then 1, then 1, then 2. So we want to get into the cycling of the boilers itself. Boilers contain a mass of water, massive heat, and you really want to be tied in with good energy algorithms to make sure that we're delivering what we need to deliver when we deliver it. With a good tritium control system and the proper programming, you can do that. Real world examples, Crate and Barrel. They had soaring energy costs they regulate everything, or they monitor everything as far as cost per square foot for electric or for gas. And they just had real high energy use. On top of it, their customers were not happy. 88% of their customers are women. They have the demographics figured out that close, and that they need a certain amount of customers in the store for a certain period of time. They have it dialed in who their customers are. And with that, they're saying we cannot have the temperatures as cold as they are, and they had changed their lighting. And they changed their lighting, they lost their heat load. So they were freezing and having a real tough time. They had an existing Carrier CCN system, nothing against Carrier or anything else, but an existing system that did not have the capability to invoke the morning warm-up at different times of the day to bring the temperature up into space. It also didn't have the building with the predictive scheduling, predictive energy modeling, to really fine-tune the energy usage in the store. We went ahead and installed a tritium front end. Again, we took that box that we looked at before, and we mounted it on a wall, and we connected to the Carrier network. We overrode all the points. We were able to get heat up for them. Everybody's comfortable. The nice part about it is it was $14,000 to do all this work, the program, the graphics, the email alarms, everything. And they're saving $18,000 a year minimum in their electrical costs. So that's somebody that says, I have a building automation system already. I don't need one. You do. You need to have the new technology. You don't need to rip out what you have. Go with a tritium-based system, have it installed, commissioned, programmed correctly, pick up some rebate dollars along the way, as long as you fit in different criteria that they have, and really make a big impact on your company. Big store, big corporation, they have a name brand automation system, of which we also rep and install. I'm not talking bad about Carrier systems, but we were able to fit the need with what we did. Next one, Vapor Bus International, manufacturing facility. Really nice to see it happening in in Illinois, not much alone, a couple miles from our office. Soaring energy costs. Energy costs are through the roof. It's really affecting the bottom line of the corporation. No control over plant temperature, ventilation. Employees, I'm too hot, water breaks, everything in the world. It was a disaster there. I get it. The people were suffering with what was going on. And with the manufacturing, you have a lot of odors, chemicals, and different things like that. Well, you need to get these things handled. And management knew it had to get handled. An energy audit resulted in $40,000 in annual savings. And they were able to get a $58,000 rebate to implement their project. So what happened here is the return on investment was 7 months. On top of that, the customers are happy, and they have their ventilation taken care of, and they're just saving money year after year. That plant manager brought in us to take care of everything. That plant manager is adding $40,000 to the company's bottom line, and everybody's healthy, and guess what? They're not breathing all the stuff from the manufacturing either. Tritium system was installed, controlled all the fans, ventilation, makeup, air equipment, done deal. And I'm going to pass it over to Donnelly Phillips, Director of Holy Cross Hospital.
Controls and steam heat exchangers. Our hospital now has temperature control. We expect a substantial energy savings and may be on track to beat the estimate. Staff has more time for preventative maintenance instead of constantly going into machine rooms to adjust temperatures. There's a significant reduction on the amount of chill water and absorber use. Lastly, there's a significant reduction in the amount of steam that has to be generated to heat the hot water system. Our rebate from People's Energy was about $150K. We probably wouldn't have been able to put that new BAS system in without that energy rebate. We expected to save approximately around $103,000 annually. I'll now turn it back over to Mike.
We compare them to the last 12 months of gas and electric bills and say, okay, this is what you're paying, this is what your building model's out at. After we're done, you're going to model out over here. And the reduction in the model, as well as the utilities going through the engineering documentation, results in the building rebate. After we're done doing the modeling and the site visit, going through everything, again, that's only one visit, maybe two to do all that. Then what we do is once we have all of our engineering studies done, all of our findings done, and what we think the approximate rebates would be, we come back and visit with you and say, okay, this is where your building's at, this is your baseline, this is where it's gonna be once we're done with everything. We anticipate this amount of rebates based on our engineering study. We provide all the information to you. At that point in time, you decide, hey, does this make sense? Does this make sense for my hospital? If it's like a 1.2 or even a 2.7 year payback, 3-year payback, whatever it is, you're gonna say, yeah, it makes sense. Let's see if we move forward with it. At that point in time, you go ahead and apply for the incentive with the utilities. It's as simple as filling out a form. Yes, I'd like to move forward in this manner. We, for you, once you sign the form, we supply all the engineering data, we supply the scope of work, we supply everything. And utilities take a peek at it, and they decide, you know, what kind of rebate dollars are gonna come back. Then, the nice part about it is you get a commitment letter from the utilities. So what'll happen is, you have us or anybody else you work with, doesn't have to be us. You have your scope, you have an engineering study where the building's at, where you need to get to, and then you have a commitment letter for the utilities that if you implement this, you will end up getting a check for X amount of dollars. Then you can go to the church elders, or you can go to the board of directors, you can go wherever you want, and you say, okay, this is the package, this is what we have, and you make a decision on it. So to get into this, to do this, is it's real easy. The energy race. There is an energy race out there. Years ago when all these programs started with Peoples, North Shore, NICOR, ComEd, you know, they're trying to get people involved, trying to get people excited and everything. We've seen a tremendous amount of excitement. We've seen a lot of people utilizing the rebate dollars from these providers. ComEd, at this time you're on a wait list because they've been so successful with their program. I honestly foresee myself personally, and I work for the utilities, since everybody's getting into it and they need to have these programs last for a long period of time, in my opinion, the incentives are going to start to scale down so they can give out more money and keep the programs going. I really would be proactive, start going after, find out how energy can be saved at your building, just so you can get maximum rebate incentives back. They're going to be around for a long time, but you know, at one point in time, they were paying out a lot of money because people weren't getting involved in the program. Now there's so many people involved in the program, I'm just thinking it could possibly go down. So I firmly believe it's an energy race, that you really need to get your stuff put together. We have set substantial, significant jobs and smaller jobs that will take 6-9 months for the process because of the board approval and everything else. We also have other jobs that are quick and they're ready to go no matter what the size. So whatever it is, just be aware that the earlier you get this going, the better, because with your process and even with the utilities approving the engineering and everything, it could take a period of time. So major takeaways, what you really want to learn from today, the takeaway with you is automate the right parts of your HVAC system for maximum energy savings and return on investment, period. That's what you got to leave this room with, and it's so important just to go after that. The next one, have an expert perform an energy study. Again, focus on maximum energy savings and lowest capitalist costs. Next one is use a company with a successful record for securing custom rebates with the utilities. Also very important. There's a lot of good contractors that are out there that work a lot with the utilities. You want to make sure you're going with them rather than some guy that just signed up as a trade ally last week and doesn't put any projects through the program. So you want to work with somebody that works well with everybody. All right, so that's all I have. A little bit of time for question and answer if anybody has any questions. Nothing, I covered everything that well. Well, I got to tell you, thanks for all your time. And if you have any questions, I'm at booth 112. Oh, go ahead, please.
Yeah, I have one. A lot of times the problem in these bigger buildings is comfort. Like second floor is freezing, 21st floor is getting their butts off, and so on and so forth. Or even within one floor, it's 2 food for one guy, 2 food for another guy. Can you address those items too in these larger commercial buildings?
Yeah, absolutely. When we actually go through and we put together an energy study, we do take a holistic approach. We're not just looking at building envelope on the outside, the glass, the exposure you have in the building load. We're looking at the mechanical system you have. In most cases during a study, we actually have to take duct pressure measurements with pitot tubes to figure out what kind of air we're delivering in different places, and that's part of our study. So when we come out, we talk about where you have problems. You know, we want to find everything about the building because you know about it more than we do. But we look at the outside, the comprehensive shell on the outside, and we also look at the inside on the mechanical end to make our recommendations. Any other questions? Please.
Hey, Mike, I was just going to mention, there's even a rebate for doing the study, so that's additional.
Oh, I'm sorry. Thank you very much, Cliff. There's too much to cover, slides and everything else. Rick, are you okay with me going through this? Okay. So depending on your building size, your usage and whatnot, the utilities do pay to have energy studies performed. In many cases, we perform an energy study on our own, no cost to the customer or whatnot. You start getting large substantial projects, such as Holy Cross Hospital, the utilities pay for those incentives. Rick, do you know the thresholds offhand?
For the gas optimization study for building heating, it's up to $10,000 for the engineering study, and if it's a process heating and manufacturing, it's up to $15,000.
Okay, so the utilities are willing to pay for these studies too. And again, it's very beneficial too. And just so you know, and so you're not nervous, oh, I don't know if I'm going to save energy or whatnot, when these custom rebates hit the utilities, it goes through a rigorous process. Let me tell you, we have to have everything documented. When I talk about building modeling, we have longhand calculations for them to go through. And it goes through about our engineering team ourselves, and we're conservative because we never want to look bad. Then it goes through about 3 levels of engineering and approval once it hits the utilities. So when you get that rebate letter, you pretty much have it guaranteed. You've had 5 sets of good eyes looking at it, 5 teams looking at it, and you're good to go.
Sure. Say, as a hospital, this is my 5th hospital I went to work for. Holy Cross Hospital is one of those safety net hospitals that I have a whole lot of money. So getting that energy saver rebate was huge for us. When I see a couple familiar faces in the audience, I actually went to work for Holy Cross Hospital about a year ago. I actually worked downtown at Northwestern Memorial Hospital up in Lake Forest for about 9 years. So not only did we actually have a new building automation system installed at Holy Cross Hospital, we also have a brand new burner installed on one of our boilers, which will help save us a tremendous amount of energy. As a hospital, as you guys know, for those of you who work in the facilities or support departments, we do not generate any revenue for the hospital. Only thing we do is spend. We try to spend wisely, but we don't generate revenue. By going and doing one of these energy studies, you can actually help to save the hospitals a lot of money. For example, I think there's an EPA report out there that says that every $1 saved in healthcare is actually